Okay, today we're going to talk about linear proportional relationships within tables and how we actually find the equation or the constant of proportionality while looking at a table. So here's an example. Megan earns $12 an hour at her part-time job. So right there, I understand that that's my unit rate. Right? So my unit rate is $12 per 1 hour. Okay? Keep that in mind is because unit rates will come back again this unit. So show that the relationship between the amount she earned and the number of hours she worked is a proportional relationship, then write an equation for that relationship. So over here, if I were to talk about my independent variable, that would be the number of hours. So this will be my x and this will be my y value. Okay, so the independent variable is always going to be your x and the dependent variable is going to be your y. The amount of money you earn depends on the number of hours you work. Okay, so for the constant of proportionality, we're going to go ahead and use this equation right here. So k, meaning constant of proportionality, is equal to any y value divided by any x value. Now, if all of these are the same, then that means we have a proportional relationship. Then we can take our k value and plug in here in order to create an equation. All right, so let's go ahead and see. So k is equal to y over x for our first one. So that's simply 12 over 1. So my k value is 12 for the first one. For the second one, once again, y over x is equal to 24 over 2. I simplify that, that's 12 over 1, which of course is equal to 12. If you want to keep it as a fraction, you certainly can, but if there's a 1 at the bottom, you should most likely just write it like this. Okay, once again, k equals y over x. In this case, we have 48 over 4. So that simplifies to 12 over 1 if I divide bottom and top by 4. But bottom and top by, by 4. All right, and then lastly, k equals y over x. So that's going to be equal to 96 over 8, which does, again, simplify to 12 over 1 when you divide the top and bottom by 8. So all of them are 12. So that means that this table is proportional. So now that I know my k value, k is 12 for all of these, so my equation is y equals 12x. All I'm doing is I'm replacing k with 12 because k is my constant of proportionality. All right? So let's go ahead and try another example. In this case, I'm given a blank table, so I'm going to have to create a table on my own. So I need to find a unit rate first. 11 bicycles are produced each hour at the Speedy Bike Works. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship, then write an equation for that relationship. So my unit rate is going to be equal to 11 bikes that are produced each hour, so 1 hour. All right, so 11 over 1, so it should be 11. Okay, so 1 hour, 2 hour, 3 hours, 4 hours, 5 hours. So right here, I can already tell what my constant of proportionality is. So k is equal to y over x. I'm already told that my constant of proportionality is 11. So I'm just going to go ahead and write that into an equation. Y equals k times x, where k, of course, is 11, my constant of proportionality. All right, now, in this case, all I got to do is plug in. This is my x value, this is my y value. So y equals 11 times 1, which is of course going to be equal to 11. So my first point is 11. Y equals 11 times 2, so 22. So my second point is 22. Y equals 11 times 3, 33, and you get the idea. So this is going to be 33, 44, and 55. Now, just keep in mind that I use my unit rate first in order to figure out my constant of proportionality. You could always think of a unit rate as a constant of proportionality. And you could always think about constant of proportionality as a slope as well, which I'm going to show that example in the next one. Okay? So let's go ahead and take a look at this. The graph shows that the relationship between the weight of an object on the moon and its weight on Earth. Write an equation in this relationship. So once again, x, y values. All right? So remember, k is going to be equal to y over x. That's my constant of proportionality. I need to write an equation, y equals kx. Now, k over here is 1, and then y is 6. So I'm not going to turn this into a decimal. I'm just going to keep my k value as 1/6. All right? So once again, k equals y over x. My y value here is 2, and my x value is 12. Divide by 2, divide by 2. This simplifies to 1/6. K is equal to 3 over 18. Divide by 3 divided by 3, 1/6. And then k is equal to 5 over 30. Now just divide by 5 divided by 5, 1/6 again. So what is my equation? My equation is y equals 1/6 of x. Okay? Y is equal to 1/6 of x. So let's just say my x value is 36. I want to figure out how much I would weigh on the moon if on Earth I weigh 36 pounds. Okay? Well, that's more like for a kid, but yeah. So y equals 1/6 of 36, because I'm replacing x with 36. So y is going to be equal to 36 over 6 is going to be 6. So y is going to be equal to 6 in this situation. All right? Now, let's say we do it in reverse. How about if we're given this as 7 and we need to figure this out right here? Okay? So what we'd have to do, we would just use the same equation. Y equals 1/6 of x, where when y is 7, 1/6 of x. Okay? So I need to get rid of the 1/6 by multiplying by its reciprocal. So times 6, we'll cancel that out, times 6. So x is equal to 42. Okay? So keep that in mind when you're thinking about this. Now, let's say that I wanted to think about slope. Slope and the constant of proportionality is basically the same thing. Okay? So this is going to be my rise over my run, which is going to be my change in y versus my change in x. And we'll definitely go over this a lot more in graphs, but I just want to show you this example really quick. So if you think about your y values, here's your change in y. You're going from 1 to 2. So how much did you change the values by? You changed it by +1. So your change in y is 1. Now, let's take a look at x, the same points. You go from 6 to 12, so you're increasing by 6. Change in x is going to be equal to 6. So my slope is 1/6, which is the same as my constant of proportionality. So when you think about unit rate, when you think about slope, when you think about constant of proportionality, they all just basically mean the same thing. So keep that in mind, especially when we get to graphs. All right, let's go over just a few more examples. At this point, if you already have a good understanding, you could move on. You don't have to watch the rest of this video. But if you want to look at a few more examples, feel free to keep looking, okay, to keep going. Eve keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rate of change are constant or variable. Okay, so k is equal to y over x. We always have to use that ratio. So we have 15 over 1, which is just equal to 15. K equals y over x, which is 45 over 3, which is also equal to 15. K equals y over x. And just use the third point on day 3, 90 over 6. So if I take 90 and I divide it by 6, I'm going to get a value of 15. So that has to be 15 as well. All right, k equals y over x. So we have 120 divided by 8. So if I take 120 and I divide it by 8, I'm going to get, once again, 15. Okay? So yes, absolutely. This is a constant rate of change. So let's go ahead and write our equation. Y equals kx. So y is going to be equal to 15x. This is the answer. So tell whether the rate of change is constant or variable. Variable meaning it's always changing, or constant meaning it's always the same. So yeah, the constant rate of change is always going to be 15x. So it's constant. Last example. So the table shows that the approximate height of a football after it is kicked. Tell whether the rates of change are constant or variable. Find the rates of change. Is it constant or is it variable? So is the speed of a football when it's kicked, is it always going to be the same, or will it change? Will it start off fast and then go slow? Well, let's go ahead and find out. So k equals y over x. So we have 0 over 0. which strangely in math you can't divide this, so this is actually undefined. Alright, so that's a little weird. Alright, so let's try the next one. We got k equals y over x, so we have 18 over 0.5. So basically we have 18 divided by a half, which is going to be equal to 36, because if I multiply by 2 to get 1, I multiply by 2, I get 36. So the ratio here is 36. So clearly these are different. But let's try the others just to make sure. We have y over x, which is 31, divided by 1.5. Alright, so if I want to go ahead and simplify this, this will simplify down to about 20.66. So 20.66, and as you can see, that's different from that. And then our last one is going to be y over x, which is 26 over 2. So divide by 2 divided by 2, 13 over 1. Alright, you can clearly see all of these are different. So this is going to be a variable rate. So it's not a constant of proportionality. This situation is not proportional at all. And that's basically it.